Welcome to Coach Eichner's Math. Today we'll be talking about exterior angles. Exterior angles are angles formed by a side of a polygon and the extension of an adjacent side. For example, if I've got a triangle, I've already drawn two sides of my polygon, and to make the exterior angle, I'm going to extend my third side, and this right here would be your exterior angle. On a triangle, there's three interior angles, so we'll talk about three exterior angles as well. Okay, looking down at example 1. For each of the following polygons, draw all of its exterior angles. So as we're doing this, we're going to draw all the exterior angles and we're just going to work around the shape. So if I want to extend one line, I'm going to extend this line out, and then I'm going to start from there and I'm going to extend out, and I'm going to extend out, and I'm going to extend out. This is a quadrilateral, therefore we've got 1, 2, 3, 4 exterior angles. Looking on, I've got a hexagon, which means I've got 6 angles, which means I should also end up with 6 exterior angles. So again, I'm just going to follow my shape around, and I'm going to extend one end of each segment to create my 1, 2, 3, 4, 5, 6 angles. So those would be the exterior angles that we're discussing. I could have drawn my lines the other direction, talked about the other 6 angles, which in fact would happen to be congruent to the 6 angles I just drew. But to us, it makes no difference which way we're looking at it. The lines will normally be drawn for you. So there's a formula to find the sum of the measure of the exterior angles of a polygon. And it's not as much formula as it is a number. The sum of the exterior angles of any polygon is going to add up to 360 degrees. Plain and simple. We know this because it's a closed figure. Because it's a closed figure, it means it had to go 360 degrees total in the exterior in order to get back to where it started. So that is our easy way to know the sum of the exterior is always 360 degrees. So if I'm asked to find the sum of the measure of the exterior angles of an undecagon is an 11-sided figure, I know right now that the answer is just going to be 360 degrees. That easy, that simple. So now, to find the measure of one exterior angle of a regular polygon. Now remember, a regular polygon is a polygon that has congruent angles and congruent sides. So in order to find the angle, one angle, I'm going to go ahead and say 360 divided by n, the number of sides or the number of angles. And that's going to equal each angle. In this case, we're going to say each exterior angle. So, pretty simple. As we're flipping over, looking at the back, example 3, find the measure of one exterior angle of an undecagon described in example number 2. Well, again, an undecagon is an 11-sided figure. We know that the sum is 360 degrees. In order to find each, I'm going to divide by 11. So each exterior angle would be 360 divided by 11. If you do not have a calculator, I suggest you grab a calculator at this time. Help you out with this. We're going to say that each exterior angle is 360. If I can get my calculator to turn on for me. 360 divided by 11, which in this case is 32.72 degrees. Excuse me, that should be 0.73 degrees because I'm going to round. So, looking down at example number 4, I suggest that you give it a try on your own. Example 4, given a regular nonagon. Nonagon is a 9-sided figure. Find the following. sum of the interior angles, and this is where it's real careful. Interior angles, our formula is 180 n minus 2, or 180 9 minus 2, which is just saying 180 times 7. So in this case, 180 times 7, I should have 1,260 degrees for the sum of my interior angles. Find each interior angle. My formula is going to be 180 n minus 2 divided by n. Well, I know that 180 n minus 2 is just 1,260 divided by n, which is 9. So let me type that in. I'm going to take 1,260 divided by 9, and I find that each interior angle is 140 degrees. The sum of the exterior angles. This should be quick, should be easy. You shouldn't even have to think about it. 360 degrees, because a polygon is a closed figure. And number D, find the measure of each exterior angle. So this is exterior, 360. Each exterior, we're going to say 360 divided by n, or 360 divided by 9. Okay, let's take a calculator and go 360 divided by 9, which is 40. Okay, so looking down at example 8, this is a bit of a review problem because we are looking at an exterior angle here, but this uses a theorem that we've already talked about. We know that there's a total of 180 degrees inside my triangle. There's a total of 180 degrees on my line, and I've got angle, we'll call it angle C, and I'm going to say minus angle C there, and I'm going to say minus angle C here, which means that these two angles must be the same as this angle. Because I've got 180 degrees, take away angle C. I've got 180 degrees, take away angle C, which means those two things must be congruent. So I'm going to say 3x plus 8 plus 2x plus 1 equals x plus 21. Looking through, that's 5x plus 9 equals x plus 21. Minus x on both sides, minus 9 on both sides. I would say that 4x equals 12, or x equals 3. Now, that's all they asked for, but if they wanted to know the measure of the angles, I could easily plug it back in and tell you that this would be 24 degrees. I could easily plug it back in and tell you that this would be 9 plus 8 is 17 degrees. And I could easily plug it back in and tell you that this would be 7 degrees. Now, notice this is not drawn to scale, and part of the reason that is so that you don't guess. Please make sure if you have problems like these that you work them out, because they're intentionally not drawn to scale to make you trust your algebra. Appreciate you watching Coach Eichner's Math. Have a great rest of your day.